Okay, I'm going to do one of these problems from this Chapter 7 graph worksheet. There's 6 of them. I'll do one of the 6, and once you get that, you should get the idea. What you should do, first of all, is when you look at the graph over here, you should divide these all up and figure out the area of all these segments. That's going to make your work a lot easier. So that's what I did first. In other words, I drew these straight lines, and I had a triangular region here. The area of that triangular region, it's got 2 by 2, because that's going down to 2, and I also gave you the coordinates there. So base is 2, height is 2, so 1/2 base times height, 1/2 2 times 2 is 4. I'm sorry, 1/2 2 times 2, which is 4, half of 4 is 2. So the area of that triangle is 2. And since it's below the graph, or below the x-axis, pardon me, it's going to be -2. And then this triangle is a 1 by 1, so half of 1 times 1 is 1/2, and this is 1/2, and this is below, so this is -1/2, -1/2. This is a semicircle. The radius is 2. Pi r squared is the area of a circle, so that'd be 4 pi. But I only have each of these quadrants, and each of these would be a fourth of a circle. You're told that it's a semicircle. So each of these is a fourth of a circle, so each of those is pi. And here we have a triangle that's 2 units by, my base is 2 and my height is 3. So 2 by 3 is 6, divided by 2 is 3, so each of these triangles is 3. So that's going to help me figure out my areas a lot faster. So do that in each of the problems first, and then make sure you're careful that you write your information down. Don't try to skip any steps. You won't make mistakes. Okay, so the first one we are told for the first 3 problems, g of 0 is -3, so I want to find g of 5. Okay, so we know that g of 5 equals, and I'm going to start with my initial part, which is going to be g of 0, and write this down, plus the integral from 0 to 5 of g prime of x dx. And we talked about this, why this is the way it is and why it works, but make sure you write it down. Don't be skipping steps, otherwise you're going to make some errors. Okay, then I just substitute. G of 0, I know g of 0 is going to be -3, and then plus this integral, I can figure out the integrals. That's just the area from 0 to 5. So if I look at the area from 0 to 5, it looks like I've got pi plus pi is 2 pi on the top minus 1/2, so that's going to be 2 pi minus 1/2. And then if I just add these up, I get -3, and -1/2 is -3.5, or -7/2, and this is a positive 2 pi. That's just going to be 2 pi minus 3.5. -3 and -0.5 is -3.5, and that's what you've got. That's all you have to do. Just have to understand this concept, because it's a very important concept that we get to do this, and even if this is 1, that would work. So if I take a look at the next one, I want to find g of 9. So g of 9, that equals g of 0, because I know that's my known value, plus the integral from that value 0 to that value 9. And that's going to be of g prime of x dx. And again, I know that g of 0 is given as -3. Let me get this up here so you can see it. Sorry about that. G of 0 is -3. All right. I'm going to put this down here so you can see this like this. Okay, g of 0 is -3. And my area, or my integral from 0 to 9, to get me to 9, for g of 9, is going to be the area from 0 to 9. So if I look over this, I've got a -1/2, and I've got, again, pi plus pi is 2 pi, 3 plus 3 is 6, so I've got plus 2 pi, and then plus 6 minus 1/2. Okay, plus 6 minus 0.5 if I want to do it like that, or that would be 5.5. And then if I just add all those up, what do I get? That's going to be 2 pi. That's going to leave it my answer in terms of pi. And then 6 minus 3 is 3. 3 minus 1/2 is 2.5, so it'd be plus 2.5. That's all you have to do. Okay? Very easy, just dealing with areas. And if you've subdivided these all up, and they're all triangles or semicircles or quarters of circles, so it should be pretty easy. All right? Now let me do the third part of this one. And this is going to be, I want to find g of negative 5. That's given to you down here. Right over there, g of negative 5. So that's going to be the same thing, follow the same pattern. I'm going to go from g of 0. That's what I have. Plus the integral from 0 to negative 5 of g prime of x dx. But here's where the problem is, because we have to make sure that when we integrate, the lower limit has got to be to the left of the upper limit, so we're going to have to reverse that, so this will equal. Now what's g of 0? G of 0 again is negative 3. And then minus the integral from negative 5 to 0 of g prime of x dx. So we've got to reverse that. So that's going to be negative 3 minus, and then I just find this area from negative 5 to 0. So I'm going to look over here, and I'm going from negative 5, that's negative 4, this is a negative 5, to 0. All right? Here's negative 5. I can write it in here, negative 5. So I'm going from negative 5 to 0. If I look over here, I've got negative 2 plus 1 is negative 1, and negative 1 and negative 1/2 is negative 1.5. So that would be minus a negative 1.5. Well, that's the same thing as negative 3 plus 1.5, and that's the same thing as negative 1.5. Okay? So that's all you have to do. As long as you can do your arithmetic, you're okay. Let me do just one of the B part problems so you can see what happens when we have a number other than 0. We treat it the same way. So I'll do 1B, the first part, 1B. And then we'll talk about the points of inflection that was also in there. Okay, 1B was g of negative 1. So now we're starting at 0, we're starting at negative 1, and that equals 3. And I want to find, first of all, g of 3. So remember, g of 3 equals, now my starting point would be g of negative 1 plus, and then I want to go from negative 1, that's because this is my starting point. I'm going to go from negative 1 to 3. All right, then I follow the same procedure, and this is of g prime of x dx. So this is going to be g of 3 equals, and then g of negative 1 here is given to me as 3, so that's my value up to that point, and then I'm going to take the area from negative 1 to 3. And if I go from negative 1 to 3, this works out kind of nice, negative 1 to positive 1, well, that's going to be what? Just negative 1. And then from 1 to 3 is pi, so it's going to be pi minus 1 plus pi minus 1. And then if I just simplify this, this is just going to be pi, and 3 minus 1 is 2. So that's going to be pi plus 2. So that's all you have to do. Okay? And the rest are done accordingly. Now we also asked you to find, when looking at this graph, remember this is the graph of the derivative, and we also asked you to find all the relative maximum, minimums, and points of inflection. Well, remember, a relative maximum is when the derivative, and we can think about it like this is g prime of x. That's what we have, and we're looking for the relative extreme for g of x. Okay, we look over here. These critical points are where we have 0. So this is just one. I'll just point to this one being negative 3. So this is negative 3 as a critical point. Negative 3, and you can see I'm negative over here and positive. So I'm going from negative to positive. So I've got a relative minimum. So if I'm changing from negative, this is my slope is negative to positive. Relative minimum, positive to negative. And this is negative to positive, and that's about it, because we want to only go from negative 5 to 8. Okay, so I have a relative max right here, because I'm changing, my slope is going from positive to negative. Okay, it's hard to see here, but this is the slope is positive, then negative. So that's what I would have. I could put that in. This would be negative 1. So let me put negative 1 in there, and that's negative. So you can see here I'm negative, and I change at negative 3, right? And then I'm positive, then I change at negative 1. So here I've got a relative maximum at negative 1, because I'm going from positive to negative, and that's the only relative max I have. Other places I'm going from positive to negative, over here, but this is outside my range because I'm just going outside my interval. That's negative 5 to 8. Okay, so I got a relative max, and we just want the x value. X equals negative 1, and then a relative min, and this is for g of x now, at x equals, and I'm going from negative to positive, add negative 3, and at 1. Negative 3 and 1. Okay? Negative 3 and at 1. And that's it. Okay, so those are the relative extrema. And then the points of inflection are where the second derivative is either 0 or undefined. That's where the slope of the first derivative changes from positive to negative or negative positive. That's concavity changing. And we could look over here. We've got these points, and this is where I have at x equals minus 2. You can see I've got a undefined. That's the derivative. This is my derivative, so the derivative is undefined at sharp turns, so I've got points of inflection. At x equals, and right here at negative 2, because I'm going from positive, the slope is going from positive to negative of the derivative, and then at 0, the slope's changing. Here it's positive and positive. This is a critical point, but concavity is not changing because it's increasing and increasing. But here it's positive and negative, so at x equals 3. These are points of inflection. Here it's going from the slope of the derivative is going from negative to positive, so that's at 5, another point of inflection, and at 7. It's going from positive to negative at 7, and that's it. So you have 5 points of inflection there. All right? So I hope that all makes sense, okay? So that's how you deal with that. Hope that helps.
Pardon interruption. People on campus, pizza for our link crew.